Hello, today we're going to talk about angle-angle similarity. You touched on this in 7th grade when we were talking about similar triangles and we compared side lengths. Remember that side lengths had to be proportional, and if they were proportional, then they were similar triangles. It's going to be very similar on this, except we're going to be talking about angles. So similar figures have the same shape, but may have two different sizes. So two triangles are similar when their corresponding angles are congruent, and the lengths of their corresponding sides are proportional. And that proportional is what we were talking about before. So if I had a say a triangle, and then another triangle, and we talked about them being proportional. If this was 2 and this was 6, or sorry, flip-flop that. If this is 6 and this was 2, and if this is 1, then this would have been 3. So these are proportional because 2 to 1 is equal to 6 to 3. Because they were proportional, then these were similar triangles. Okay, do you remember that? Today, we're going to talk about the angles. So this time we're going to be looking inside the triangles. So we're going to use a protractor and a straight edge to draw a triangle. And actually, I'm just going to go ahead and draw it. And we're going to have one angle measure is 45 degrees and another measure is going to be 60 degrees. And I'm going to use my tools on my program here to be able to do that. So I'm going to get my protractor out, and we're just going to move it over here to the side. And so the first thing I'm going to do is I'm going to draw a line, and then I am going to draw the angle that is 45 degrees. So any point on here, and I want it to be 45 degrees, so it'll be somewhere in this ballpark, right? A little bit up from there. There. And then I'm just going to draw from this point to this point, and that makes this a 45 degree angle. So this is a 45. And then it says the other measure is going to be a 60 degree angle. So anywhere on here, I'm going to put a point, and then I'm going to bring my protractor over and I'm going to line it up right there. And then I'm going to come down here to 60. Up there. And then I'm going to draw a line between this point and this point. And that's my 60 degree angle. And then this is going to be my unknown. So let's do N. I can clean this up by erasing some of the lines. There's my triangle. Alright, so compare the triangle to those drawn by your classmates. How do the triangles, are they the same? As long as you have a triangle that has a 45 degree angle and a 60 degree angle, N is always going to be the same. So if we were to figure out what that third angle is, if I have a 45 degree angle and a 60 degree angle and I add them together and subtract it from 180, I get 75 degrees. So I know that my unknown is 75 degrees. Okay. How they may be different is, what if I decided that I was going to draw it where I had a 45 here and a 60 here, then this would have been my 75. It doesn't matter how I have them as long as they have the same measure. They may not look exactly the same, but these are exactly the same. If I had used the protractor, they'd be exactly the same triangle. So maybe they're facing a different direction, or maybe they have the numbers in a different order. Maybe you decided to do 60 on this side and 45 up here, and then that would have been 75. So just how they're different is just by how we place them. Okay? All right. We can use the AA similarity postulate to solve. So it says that if two angles of one triangle are congruent to two angles in another, then the triangles are similar. And the reason this works is no matter what the two congruent ones are, if you add them together and they're the same in each, your third angle is always going to be the same. Okay? So explain whether these triangles are similar. So I have an angle of 100 and an angle of 45, and I have an angle of 100 and an angle of 35. Well, if I take and subtract the sum of those two angles, so that would be 140, and then subtract that from 180. Oops. And that's going to give me 40. And if I take this one and I subtract 135, so that's 145. Oh, wait a minute. There, 35, sorry. Good thing I double checked my math. Because I know that it has an angle of 100 that matches, and an angle of 35 that matches, I automatically know, without even having to do additional math, that this is going to be 45 because two of my angles are exactly the same. Okay? They want to know if all right triangles are similar, why or why not. Think about it. If I have a right triangle, let's see if I can draw one here. A right triangle. So if I have this right triangle and I have this right triangle, we want to know, are they always going to be the same? We know for sure that they have a 90-degree angle because it's a right triangle, right? But do I know for sure that these angles are always going to be the same? No. Remember, it has to have a minimum of two angles being congruent for it to be similar. And if they're not, then even a right triangle could be not similar. It may look similar, but it isn't. All right. Explain whether these triangles are similar. So what I want you to do is find the missing angle measure for N and the missing angle measure for Q, and then tell me, are these two similar or not? So I found the missing measure for N, and it was 52. And I found the measure for Q, and it was 61. And the reason it is not similar is because they only share the one set of congruent angles. The other two angles are very different. So these are not similar triangles. Explain whether triangles are similar and label the angle measures in the figure. So we have triangle ABC. So we have angle A is 41, angle C is 30. And we don't know what B is. And then on DEF we have 109 and we have 30. So we need to know, do I have two sets of congruent angles? All right, so angle ABC has angle measures of 41, 30, and 109. So 30, 41, and 109. And DEF has angle measures of 30, 41, and 109, because at least two angles in one triangle are congruent to at least two angles. In the other triangle, the triangles are similar. Okay. All right, let's take a look at number 3. Two transversals intersect two parallel lines as shown, and they create angles or triangle ABC and also CDE. Okay, or DEC, either way you read it. We want to know if they are similar or not. Okay, so we know that this angle and this angle are the same. And we know that this angle and this angle are the same if I just go by alternate interior. And we know because of vertical angles that this angle and this angle are equal to each other. So are they similar? Well, we know that the two triangles are similar since they are congruent, or they have congruent angles. And ABC and DEC is just another way of wording these triangles. They're also congruent. So all three angles are congruent. Finding missing measures in similar triangles, we can use what we know to find our missing angles. When playing tennis, Matt is 12 meters from the net, which is 9/10 of a meter high. He needs to hit the ball so that it just clears the net and lands 6 meters beyond the base of the net. At what height should Matt hit the tennis ball to be able to hit that? So here's Matt, and he has 12 meters from the net, and then there's an additional 6 meters here. So from A to D, the length is 18 meters. And we know that he is a certain height. Both triangles contain angle A. So you see this triangle here. So we have this triangle. And then we have the bigger triangle. Oops. And what you notice is that they both share angle A. So that means that this angle is the same for both. This is at a right angle, and this is at a right angle, so I know that they are similar. And in similar triangles, corresponding side lengths are also proportional. So I know that this side is proportional to this, and this height is proportional to this. And I can use that to determine at what height he needs to hit that tennis ball. So I have my 18 for my long side, so it's 18 over 6 is equal to my DC, or BC is here, so little triangle, and my big triangle is H. Knowing what I know about proportional relationships, I know that if I cross multiply and divide by 6, I'm going to get 2.7. So he should hit the ball at the height of 2.7 meters. Okay, let's try another one. Rosie's building a wheelchair ramp that is 24 feet long and 2 feet high. She needs to install a vertical support piece 8 feet from the end of the ramp. What is the length of the support piece in inches? So here's our small triangle. Here's our long triangle. And we're going to set up our proportion. Long triangle. So length to height and length to height. I happen to know that if I multiply 8 times 3, I get 24. So if I take 2 divided by 3, I get 6.7 or 0.67. So 67 hundredths of a foot. The lower cable meets the tree at a height of 6 feet. So here, somewhere in here is 6 feet. Maybe I'll do a different color. Let me get red. So this is 6 feet and extends out 16 feet from the base. So 16 feet here. If the triangles are similar, how tall is the tree? So I know that from the tree to this point, if I tie it off from the top of the tree, is 56 feet. And I want to know what the height of the tree itself is. So I can do height to length, height to length. I can multiply both sides by 56 to get rid of my fraction on that side. And I can take 6 divided by 16. Oops. 16 times 6 divided by 16 equals 0.375, and multiply that by 56. I get 21. That simples out. Then I get 21 equals h. So the tree is 21 feet tall. Okay, a flagpole casts a shadow 23.5 feet long. At the same time of day, Mrs. Gilbert, who is 5'5" tall, casts a shadow that is 7.5 feet long. How tall in feet is the flagpole? So here's 16 feet and 75 or 7.5 feet. The shadow all the way is 23.5 from here to here. Mrs. Gilbert is 5.5 feet tall. She casts a shadow that's 7.5 feet long. Find the height of the flagpole. So we have our height to our length, our height to our length, and I want you to simplify to find what h is. When remembering to answer this with a rounded to the nearest 10th answer, we get 17.2 feet. There's some real-world problems that you can work. I would suggest drawing them. We'll do this one together, and then you can work on a few in your notes. Make sure you talk to your teacher if you're struggling with this. It says Sheila is climbing on a ladder that is attached against the side of a gym wall. She is 5 feet off the ground and 3 feet from the base of the ladder, which is 15 feet from the wall. Draw a diagram to help you solve the problem. How high up the wall is the top of the ladder? So here you have your gym wall, and we know that it's always going to be at a right angle. And then you have this ladder that she's climbing. She is 5 feet off the ground and 3 feet from the base of the ladder. So she's, say, here. So this is 3 and this is 5 feet. The 15 feet from the wall is the bottom of the ladder altogether. And we want to know how tall, how high up is the top of the ladder. So from here to here. Remember, there's several different ways you can set up your proportion. You can do wall floor to ladder floor, or you can do wall to height, floor to floor. Either one's fine. I happen to like to keep them together, so I'm going to do h to 15 and 5 to 3. And you solve to find out how high the ladder is. And I got 25 feet. If you have any questions, talk to your teacher. Thank you.